Hello everyone. In this video, I want to show you how to use Vernier Video Analysis to analyze a video, any video, but specifically we can use it to analyze Car2's video. And so if you open up the link where for Vernier Video Analysis, it should take you to this screen. And there is a button here for import video. And the idea here is that you're supposed to select the video that you want to analyze. If you didn't download the video, then that's the first thing you need to do. Um, But after you download the video, it should be wherever all your files download. For me, it's in my downloads folder, so I'm going to click on the video right here. And when I open that up, you should see the video pop up on your screen. There are these graphs off to the right. For now, I'm not going to go into what those graphs represent, although they are super useful and they give us a lot more information than what I'm about to show you. And if you want to understand how to use those graphs to analyze the motion, watch the separate video I'm going to post. But for now, I'm going to click this button and just slide these graphs off to the side so it makes my video bigger. First thing I want to do is show you how to create a dot diagram for analyzing the motion. And if you don't know what a dot diagram is, I recommend reading the article that was posted by your teacher before watching this video. You can just pause it for now. So if I play this video at the bottom here, I can hit play. I see that a ball rolls down a ramp. It's a ball rolling down a ramp, so you can imagine it's probably speeding up. But how can I prove that? How can I prove it's speeding up? Maybe this is some sort of trickery and it's not actually speeding up. And so what I can do is back up in my video, find where the ball first gets released. So when I first want to start analyzing its motion, looks like it's somewhere there. All right, I'm going to say it's right there. Okay, so that's about where the ball gets first released. What I'm going to do is I'm going to add dots to this picture. And the way you do that is in the top left corner, it says add. And so if I click on that, I can add a dot. But I want to make sure that I add the dot in a very specific spot because I'm trying to keep track of the ball. And whatever spot you choose should be the same spot each time. For now, I recommend always choosing a spot near the front because as the ball, for example, in this situation, as the ball moves forward, you'll notice it gets blurry. And so finding the center or the back or anything like that becomes tricky and unreliable. But the front of it should always be pretty reliable. So what I'm going to do is I'm going to try to zoom in on my video. And if you have a mouse wheel, you can use the mouse wheel. Or if on a Chromebook, you could probably use 2 fingers and scroll up on the touchpad and down to zoom out. If I click somewhere near the front here, you'll notice that the dot was placed and then the video skipped forward. But it didn't skip forward that much. So now it's kind of hard for me. Maybe the next point is here. And see how they're kind of like right on top of each other? The next point is here. The video keeps advancing, but not that much. In fact, in this last frame, it didn't really advance at all. To avoid this issue, I'm going to start over. I'm going to delete these dots. So on the left here, it says edit. I'm going to click on edit, and then I'm going to click on these dots, and I'm going to hit backspace or delete on my keyboard, and that should delete them. What I need to do is I need to change the settings. I need to change how much forward the video goes after I make a dot. So it changes the amount of time that passes. In the bottom right corner here, you'll see a gear, and that gear is going to let you change the settings. So if I click on that, it says advanced frames. I want to make that like 5. I think 10 is too much. 5 is probably like a good number, but you can decide for yourself. You can play around with it and always delete the dots if you don't like it. All right, let me find where the ball was just released again. Yeah, somewhere there. All right, so here's what I'm going to do now. I'm going to click on the front again. But now you see the video advanced a lot more. So it's a lot easier for me to track this. Plus, I'm going to make less dots, which is easier for me, and I don't want to click a bunch because I am lazy. All right, here we go. Keeps advancing. And so you see that as we're making these dots here, we see a certain pattern. Okay. So maybe I need to zoom in for this one. So it's tricky, somewhere there. And last one is somewhere there. Okay, so if we look at this by zooming out now, we can see that a couple things right now. First off, we can see that in this time interval, so between this dot and this dot, is the same time interval as this. All these intervals are the same. But look at the distance the ball moved. The ball moved way more in that last interval than it did in that first interval. So if you have a dot diagram, you could use this as an argument. You could say, hey, if you look at the interval between, let me say that differently. If you look at the distance the ball traveled in that last moment of time, that distance is clearly larger than in that first interval of time. So based on this, I know that the ball was moving faster at the end than it was in the beginning. And if it's moving faster in the end than in the beginning, it must have sped up. This ball is accelerating, it's speeding up, right? So that's one conclusion I can make. To be a little more scientific, you could also use a ruler. And so what you could do is if you click on the system here, sorry, it says system here, there's a scale. The video has no idea what 1 meter is or 2 meters. You have to tell the computer like how much is this distance, kind of like on the map. You have to create a scale. So I know in this video that from here to here, so I can move these, I know that this is 1 meter. I know that. So I can go up here and I can select that. So 1 meter. Or if I want to make it centimeters, I can make it 100 centimeters. Create whatever scale I want. And if I'm wrong, it doesn't know I'm wrong, right? Because I can say this is 1 mile. The computer doesn't know. You're telling it what the scale is. So if you're analyzing any video, you have to know something's measurement in that video. For me, I know that this ramp is 1 meter. You could look up what is the length of a car, a Subaru car, like in the court case that you're analyzing. All right, so once you have your scale, the next thing you got to do is you click on origin, and you got to kind of set up like which direction the ball is moving. So like we want it to be moving in one dimension. So it's going to be moving in this way. So we're going to make this like the number line that it's going to be keeping track of. Okay, and so what I'm going to do is I'm going to say something like that. This is where I'm going to say is my start. That's like my 0 point, and then the ball moved, or the ball moved down the ramp that way, and I could draw an arrow, I suppose. So the ball moved like that down this line. Okay. And so now once you have your scale and your origin made, you can use your data table in the bottom right corner here to figure stuff out. So if you look at these 2 dots here, each of these dots corresponds to some of these data points in the graph. And so what you could do is you can say, okay, these 2 dots are these 2 data points. And so I know how much time passes between these 2 data points. And I can also see how much my position changes, because the ball was at a position of 0.880 here, and then it was at a position of 0.1009. So you can do your own math. You can say, okay, let's see, how much did it move and how much time did it take? And you can figure out what the velocity is. But what's great is that it just tells you. It tells you here, right? It's about 0.83, 0.81 if you do the math, maybe 0.82, right? So, and that's in meters per second. And so I know how fast that ball is moving based on these data points. If I look at the first 2 data points right there, that corresponds to here. Oops. That corresponds to here. And so I know that in the beginning, the ball started at this position, and then it moved to that position. So there's a change in position here, or distance traveled, and there's a time. And based on that, I can figure out the velocity. I can do it by hand, or I can just look on the graph. It says it right here. Okay, and it's important we look at x, not y. That's why we set up the system. That's why we oriented which way the ball was moving. So that's moving in the x direction. And so clearly the ball was moving 0.15-ish, 0.11 meters per second-ish in the beginning, which is less than in the end. And so from that, we can make the same sort of conclusion we made before, which is the ball was speeding up based on the initial velocity and the final velocity. If you have any questions about that, make sure you ask your teacher. That is all.